Hello everyone, my name is Eduardo Cortez, and today we will be discussing dynamic nuclear polarization NMR, or DNP NMR for short. We should all be familiar with NMR, but dynamic nuclear polarization, that is a phenomenon in which high-spin polarization, which is typically derived from free radical electrons, is transferred to a nuclear spin path. What this does is that it enhances the difference between nuclear energy levels, and it results in the production of much greater and enhanced NMR signals for detection. And DMP NMR is specifically used for a solid state. Now, what this measures is typically the same thing as a standard NMR. You will see it'll measure chemical shifts, NMR spectra, nuclear spin, and the shielding. Now, something interesting that a standard NMR does when measuring solid state is shown right here on the plot on the right over here. Now, we see in the solution state, we see those very nice clean peaks. But once you start measuring solid state, you see the broadening of the peaks, which isn't very accurate in terms of data. Now, you could see some peaks might conjoin together, which could be an issue, and we don't want that to happen. Now, how the DMP NMR works is that it transfers a high polarization of electron spins to nuclear spins, and this is driven by microwave irradiation of unpaired electron spins. And the main components of a DMP NMR would be a microwave source, NMR probe, and the corrugated waveguide or transmission line. The probe is it's used to excite nuclear spins and detects the NMR signal. The probe is placed into a magnetic field at its center, and then the sample is then inserted into the probe to conduct the study. For the microwave source, that is actually called the gyrotron isolator. This system generates high-power microwave radiation. An annular cathode launches an electron beam, and then advances it through a superconducting magnet. The beam is then compressed when it moves through a vacuum tube into a resonant cavity. From there on out, it's converted into transverse kinetic energy into microwaves. We could see the sample right over here on the bottom left being converted into the microwaves, which then then get converted into an NMR signal. The conditions are under 100 degrees, 100 Kelvin, which is very cold, and this is actually done to done to facilitate DNP, because that is how it goes under these extreme cold conditions. Now, the distinct qualities of a DNP NMR, we see the fast magic angle spinning and the DNP. Magic angle spinning is actually a technique used in solid state NMR and employs the principle to remove or reduce the influence of varying magnitudes or anisotropic interactions, which therefore increases the spectral resolution. Fast magic angle spinning also enables superior decoupling of dipolar interactions, which provides favorable relationship properties and even allows for proton detection. And we also see signal enhancement, which are shown on the top right figure right over here. And to overcome the sensitivity restrictions posed by standard NMR, DMP NMR has become much more popular in that aspect for solid state. Signal enhancements range from a factor of 20 to 400, which is insane. Now, DMP NMR is acquires data at a much faster rate compared to standard NMR. This is extremely useful for solid state of pharmaceuticals, from the drug delivery to up to the formulation development, and it's very useful in small organic molecules to be able to attain accurate NMR data. And that is all I have for today. Hope you guys have a great day, and thank you very much.